Hi guys, let's solve the following analytical problem together. So it says in the diagram below, A, B, and C are the vertices of triangle ABC. So A, B, C here form this triangle. So they're going further to say that AD is drawn such that D is the midpoint of BC. So for line segment BC, D is the midpoint. So the first question says determine the gradient of BC. So they want us to find the gradient for this line segment. So we need to apply the gradient formula. So notation is important. Small letter m, gradient of BC is equals to change in y, which is yc minus yb all over xc minus xb. So yc is 6 minus yb is 2 all over xc is 4 minus 8. So this here is equals to 6 minus 2 is 4 and 4 plus 8 is 12. So this is 1 over 3. Second question says calculate the length of BC. So to find the length of BC, we can apply the distance formula. So we can say BC is equals to the square root of xc minus xb the whole squared plus yc minus yb the whole squared. So we can just substitute. So xc is 4 minus xb minus 8 the whole squared plus yc in this case is 6 minus 2 the whole squared. So now we can just reduce this. 4 plus 8 is 12, so this is 12 squared plus 6 minus 2 is 4 squared. So this is equals to 12 squared is 144 plus 16. So this is equals to the square root of 160. And 160 can be seen as 16 times 10, which is equals to 4 square root of 10. The next question says determine the value of k. So they want us to find the y coordinate of D. So here we need to apply the midpoint formula because this point is the midpoint for the line BC. So we need to apply the midpoint formula. So we can say that the midpoint of BC is equals to D, which is equals to xc plus xb over 2 and yc plus yb over 2. So we can just substitute. So xc is 4 plus minus 8 over 2 and yc is 6 plus yb 2 over 2. So 4 plus minus 8 is equals to minus 4 over 2 and 6 plus 2 is 8 over 2. So this here is equals to negative 2 and 4. But remember we have the coordinates of BC to be negative 2 and k. So we can equate the coordinates respectively. So negative 2 is equals to negative 2 and therefore k should be equals to 4. So therefore k should be equals to 4. So for the last question they say is AD perpendicular to BC? Show all calculations. So they want us to show that AD is perpendicular to BC. In order to prove that those two line segments are perpendicular, we need to apply this important property. That is, if the gradient of AD times the gradient of BC is equals to negative 1, then we can say that these two are perpendicular. So we have the gradient of BC already to be 1/3 So all that we need to do is we need to find the gradient of AD. So we can apply the gradient formula. AD is equals to change in y, which is yd minus ya, all over xd minus xa. So yd is 4 minus 7 all over xd is negative 2 minus xa is negative 3. So this is equals to 4 minus 7 is negative 3 all over minus 2 plus 3 is positive 1. So this is equals to minus 3. So let's check. Let's test. MAD times MBC is equals to MAD is 1 over 3 multiplied by negative 3, and this here is equals to negative 1. So therefore we can say that AD is perpendicular to BC. So whenever you want to show that two line segments are perpendicular, you need to prove that the product of their gradients is equals to negative 1. That is, if you multiply the two gradients, they should give you negative 1. Thanks for watching.